In this video we're going to complete example 3, and we're actually going to be looking at special expansions. And there are two types of special expansions we're going to look at. We're going to look at what are called perfect squares, which are questions A and B. And we're also going to look at what are called the difference of two squares, and that's questions C and D. So before we get into our example, I just want to explain the difference between perfect squares and the difference of two squares. Okay, so a really simple example of a perfect square would be x plus 2 and then squared. Okay, and then an example of a difference of two squares, and I'm going to pick an example that looks very similar to this one, is this. X plus 2 and then x minus 2. Now when someone compares these two examples, at first thought they might go, these actually look very different to me. But remember, when you square something, that's the same as timesing it by itself. So for our perfect square, we can rewrite this as x plus 2 again. And now they look very, very similar, with a very slight difference, and that is that the one on the left has a plus in both sets of the brackets, and the one on the right has one plus and one minus. Now, even though both examples here look very similar, when you expand them, you get very different results. So quite often people get really mixed up between the difference of two squares or perfect squares, and they end up expanding it wrong. All right. So what we'll do is we'll get into our examples, and then we'll have a little discussion at the end about how people can get mixed up between perfect squares and the difference of two squares. So we'll start with example 3a, and we're expanding n plus 5 squared. Now I've got two formulas here, and I'll talk about them later, but first I'd like to expand it the way I taught you in the previous video. So first of all, I'm going to write this twice. I'm going to write it as n plus 5 twice. Okay? And if you want to make sure that you get this one correct or expand it correctly, this is probably the best way. This way you won't get too mixed up. All right, the next step is to look at the first set of brackets, the n plus 5, and we'll take the n first, and we're multiplying this n by the whole set of second brackets, so by the n plus 5. All right. In case you're a little confused with what I'm doing, I've already covered this in the previous lesson, so you'll need to go back there. Then we've got plus 5 second. So all right, plus 5 here, and then we write the second set of brackets again, n plus 5. All right, so we're going to multiply the n by the n as well as the 5, and we're going to multiply the 5 by the n as well as the 5. So let's do that. N times n is n squared, and then n times 5 is 5n, and then 5 times n is 5n again, and finally 5 times 5 is 25. And then finally we need to simplify this, and the only thing we can really simplify are the middle two terms. And when you expand these, you're always going to find that only the middle two terms seem to simplify. Okay? So we're going to get n squared plus 10n plus 25, and we've finished expanding and simplifying this expression. Alright, so let's now look at these formulas up here on the top right. Now these formulas are actually like shortcuts, and we can expand this using this formula without taking so many steps. Now the problem is that some people don't really want to memorize formulas. And the reason they don't want to do that is it's just more things to memorize. And they go, okay, well, I'm not going to bother doing this. I'm just going to keep using the longer method. I'm not going to use the shortcut. But you actually need this formula later on. You're going to need this when you learn to factorize. Okay, so it's very important that we cover these shortcuts. All right, so let's expand and simplify question A again using the formulas this time, the shortcut. Okay, so what you'll notice inside the brackets there are two terms, n and 5, and we're going to square each of these separately. So what do we get when we square n? Well, we get n squared. And what do we get when we square 5? Well, we get 25. All right, and I'm going to leave a gap in the middle. The next thing we're going to do is we're going to multiply these two terms together. What's n times 5? Well, we're going to get 5n, and I'll just write it up here. This is what I got when I multiply the two terms together. And after multiplying them together, I'm going to times them by 2, which basically means to double them. And 5n times 2 is 10n. Okay? And that will actually give me the middle term. And you can see that we got the same result here as we got down here without all the steps. And that's what the formula is telling you to do. It's saying, given you've got two terms, and then in this case it's a and b, you square them separately. So see how we got a squared, so we squared the a, and then we squared the second term, b squared. And then, according to the formula, we multiply the two terms, the a and b, and we also times them by 2. So sometimes, rather than memorizing the formula, I just kind of memorize the steps. Square them separately, n squared and 25, and then times them, and then times them by 2 to get the middle term. All right, let's do question B now. I'll do it using the long method, and then I'll do it using the shortcut. So the long method involves writing it down as two sets of brackets. So 2 minus 5b, 2 minus 5b. And then next, we look at the first set of brackets and we go, okay, we've got 2 and then minus 5b. So I'll write the 2 down first, and then the second set of brackets right next to it. And now I'll write the minus 5b down, and then the second set of brackets. I just want to remind you that this method I'm using was explained in more detail in the previous video. I now multiply whatever term is in front of the brackets by each term inside the brackets. So 2 times 2 is 4. Then 2 times negative 5b is negative 10b or minus 10b. Negative 5b times 2 is minus 10b. And then negative 5b times negative 5b, that's a double negative. So we get a plus here. And 5 times 5 is 25. And because we had two b's, we get b squared. Okay, and you'll notice in both questions, A and B, that these two middle terms happen twice. You get the same two middle terms, 5n on this side and minus 10b on this side. All right, so let's simplify this. We simplify it by collecting the two like terms in the middle. Minus 10b gives us minus 20b. And then we're going to add 25b squared. Okay, so let's expand this again using the shortcut. So I'll do it in green. So the exact same steps as I did in question A. I square the first term inside the bracket. So I square the 2. 2 squared is 4. And now I'm going to square the second term. Now when you think about it, it's not, the second term's not really 5b. We've got to treat it as negative 5b. And what do you get when you square negative 5b? Square that. Well, squaring just means timesing by itself, right? And negative 5 times negative 5 actually makes positive 25. And then b times b gives us b squared. So we didn't really need to focus on that negative there, because when we squared it, it became a positive anyway. All right, now we need to find that middle term, and we do that by multiplying the two terms together. So we're actually multiplying 2 by negative 5b, which gives us negative 10b. Remembering that whatever you get, you need to multiply it by 2, giving us negative 20b. And that becomes our middle term here. And you can see that once again, we got the same result as we got at the bottom. Now looking at the formula again, this time we're actually using the second formula because we had a minus sign here. This is why we refer to the second of the perfect squares formula. And you'll notice it's the same thing again. Whatever a is, you square it. Whatever the first term is, you square it. Whatever the second term is, or b in this case, you square it. And then, for the middle, you multiply the a and the b, and you also multiply it by 2. And the only thing that makes the second formula different is that they just write down that you need to have a minus sign in the middle, as opposed to the plus sign. Now you may have noticed when I take the shortcut, I don't actually refer to the formula. I just kind of know the steps that I need to take when I take the shortcut. And that's perfectly fine. You can do it the way I'm doing it. Because for some people, looking at the formula is a bit confusing. All these A's and B's can throw people off, and they're just better off remembering the steps. Anyway, let's now move on to questions C and D. We're going to do the difference of two squares now. You'll notice in question C here, and we're trying to expand and simplify them, both sets of brackets look very similar, except that one's got a minus symbol and one's got a plus symbol. And that's something you'll notice. You'll see that also in question D. They're exactly the same terms, 2x and 7y, except one's got a plus and one's got a minus. And when you see this, you know that this is an example of difference of two squares. Okay, but they have to both be exactly the same, bar the minus and the plus symbol. Anyway, let's expand them using the longer, more traditional method. Here we've got x and then negative 6. So we'll write x down first. Okay, and next to x, we're going to write our second set of brackets, x plus 6. Next I've got negative 6, and next to that I'm going to write x plus 6 once again. Okay, and we're going to multiply x by both values inside the brackets, and we're also going to do the same with the negative 6. So x times x is x squared. X times 6 is positive 6x, or plus 6x. Negative 6 times x gives us minus 6x. And then finally, negative 6 times positive 6 gives us minus 36. Okay? And you'll notice, just like when we had perfect squares, the two middle terms look pretty much exactly the same again. But the difference is one's a plus and one's a minus. So when you add 6x and then take away 6x, what happens? Well, they actually cancel each other out, which means that we're left with x squared minus 36, which is really nice because we've really shortened our expression, and I really like the difference of two squares because you're trying to simplify it, and it simplifies really nicely. Right, let's now look at the shortcut. The shortcut is basically this. You square the first term, which is x, so you get x squared. Remembering that both sets of brackets actually kind of have the same terms. They both have x and 6. The only difference is the plus or minus. So it doesn't really matter which set of brackets you look at. Either one's fine. So we square the x, and then we square the 6. And 6 squared is 36. And then after doing that, you just put a minus sign between it. Okay, so I probably should have written that in green, but I'll just circle that in green. So that's my shortcut there. Notice that they're exactly the same. And this is a really good shortcut, and it's really worth remembering this shortcut. And you can see it up here. They're just saying, if the first term is A and the second term is B, then square the first term A, square the second term B, and put a minus sign between it. But once again, I don't really, I guess, use the formula. I just kind of know what the formula means to do, and I just kind of do it. And I recommend doing that. I personally find that easier. All right, so let's do question D now. And this time, I'll do it a little differently. I'm going to use the shortcut first this time, and then we'll use the longer method and see that we get the same thing. Okay, so I've got two terms. I've got 2x and 7y. What happens when I square 2x? Well, that's the same as saying 2x times 2x. 2 times 2 is 4, and x times x is x squared. So I'm going to get 4x squared. And then if I square the second term, which is 7y, that's just 7y times 7y when you square it. 7 times 7 is 49, and y times y is y squared. So I get 49y squared, and I just need to put the minus sign between them. I just want to emphasize something here. When you do the difference of two squares, it's always going to be a minus sign between them. It's not going to have the plus symbol. It's very important that you remember that. Okay, so let's do it the long way now. In my first set of brackets, I've got 2x and 7y. So I'm going to write 2x next to my second set of brackets, 2x minus 7y. And then positive 7y next to my second set of brackets, 2x minus 7y. And then I'm going to expand this by multiplying, like so. 2x times 2x is 4x squared. 2x times negative 7y, 2 times 7 is 14. It's got to be minus, that's a positive times a negative. And I had an x and a y. So I'm just going to write 14xy. Next I'm going to go 7y times 2x, and these are both positive. 7 times 2 is 14, so plus 14, and I had a y and an x, so I'm going to write xy. And finally, positive 7y times negative 7y. We've got a positive and a negative, so it's going to come out with a minus sign. 7 times 7 is 49. And then y times y is y squared. And once again, because the middle two terms are the same, but one's positive and one's negative, they cancel. And I'm left with just the outside terms. I'm left with the 4x squared and the 49y squared, and it should have a minus sign between it. Some people might be a little confused right now because I've got the minus sign there and the minus sign there. I actually, when I cancelled the 14xy, I should have cancelled off that minus and plus with it. Okay, so we're left with 4x squared minus 49y squared, which is the same as using the shortcut. Alright, now before we conclude this video, I mentioned that people get confused between the difference of two squares and perfect squares. So I want to go back to those really simple examples I showed you at the beginning. Because if we look at the second one, the difference of two squares, that's really easy to expand. I can just go, well, x when I square it is x squared, 2 when I square it is 4, and then I put a minus sign between them. But the problem is, when people see something like this, x plus 2 squared, they imagine it like this, and they try and expand it using the rules that they learn from the difference of two squares. And they go like this. They go, oh, square the x, x squared, square the 2, 4. And because this has a plus there, they put a plus between it. And this is just completely wrong. I'm going to put a red X there. You can't do that. And you can just see how easy it is for someone to get confused between the difference of two squares and perfect squares. And there's quite a few things wrong here. One thing is that, as I mentioned before, when you use the difference of two squares, it's always going to have a minus sign there. So as soon as you see the plus sign, you can see something's really wrong. And when you do perfect squares, you don't end up with just the outside terms. You're going to have something in the middle. So yeah, you will have x squared and you will have 4, but you need to put something in the middle. And to get that, we just multiply them together. X times 2 is 2x. And then you also times that by 2. So you get 4x in the middle. Okay, so very important that you don't get yourself confused between perfect squares and the difference of two squares. Anyway, that concludes our video on example 3. Remember to read the description below for links to workbooklets that relate to this video.